So welcome to topic 4, lesson 4. And this is a two-parter. So we're going to talk about some standard deviation and variance a little bit more today. And then we're also going to be talking about if you change a data set. Like, for example, if you take each value and you add 4 to it, or you multiply each of these values by 3, what's going to happen to your mean, what's going to happen to your standard deviation, and what's going to happen to your variance, okay? So we're going to talk about what each of this means. But before we do that, let's get back to our lesson and slow down a little bit on standard deviation and variance. Okay, so the first thing we do need to know is standard deviation. The symbol for that is sigma x. Okay, and this variance, all that is you're taking the sigma x, which your calculator does give you, and you're going to square it. So for example, let me turn my calculator on real quick. So this is from a previous set of data that I did, and you see the sigma x is 52.714. So your calculator does give you the standard deviation. It doesn't give you the variance, but you just need to take that number, 52.714, and square it to get the variance, okay? So let's talk about what this means. All right, so if you have a set of data and it is normally distributed, we're going to talk about this a lot in this unit. What that means is it's going to look like a bell curve. So if I want to draw this a little bit better, right? So what we do know about our set of data here is right in the middle is going to be our mean. And the standard deviation is just if I take this and I go like this right here, this is one standard deviation above. So I'm going to do the mean plus sigma, right? And then over here to find this value right here, I'm going to do the mean minus sigma. And I can go 2 standard deviations above if I wanted to. So this is going to be mean plus 2 times standard deviation. And this is going to be the mean minus 2 times the standard deviation, okay? And so what is standard deviation? What does that mean, right? If you have two sets of data and one looks something like this and the other one looks like this, the first one, right, this is still our mean, this is still our mean, has a smaller dispersion, right, or spread of the data versus if you have this, right, which has a larger spread or larger standard deviation, right? And if you could see that because this one is a little bit, the first one is a little bit more narrow, whereas the second one is a little bit larger, right? It has a little bit more varied. The notation again is sigma x or OX. And in the calculator, we talked about this, right? If you look at the calculator, we do have a SX and we have a OX. This stands for sample and this stands for population. And this is a pro tip for SL. All right, we're only going to use this sigma x, okay? We're only going to use that notation. We can assume that it's for the population, so definitely star that note, all right? Variance, again, the symbol is, right, sigma x squared, so that is variance. Um, there is a formula given over here in this box. It is not needed for SL. You do not need to memorize it. However, when might you use this? If you're going to do your IA and you're going to do this, right, then you could go ahead and find out these values. And then you could literally just take your value and then subtract the mean from it, right, whatever that is. And then this just tells you like how far away from the mean is your data, how far the values are from the mean. Okay. Definitely have the calculator to find the variance, have the calculator find the standard deviation, and then just square it. So this is another pro tip for you to know. And again, like I said, the formal equation is not needed. Okay. This is the main part of our lesson. So if you have a set of data, right, like if I have 5, 7, 9, 3, 2, what's going to happen if I add 4 to each of these values, right? So let's add 4 to each of these. So 5 plus 4 is 9, 7 plus 4 is 11, 9 plus 4 is 13, 3 plus 4 is 7, and 2 plus 4 is 6, okay? So what is going to happen to our mean and standard deviation compared to the original one? So let's go ahead and figure this out. So to find my mean and standard deviation, I'm going to go take my calculator, I'm going to clear it. So second plus 712, right? Let's clear that. And then I'm going to hit stat and put my numbers in. So go to edit, and I'm going to put my numbers 5, 7, 9, 3, 2. And let my calculator do its job, right? So hit stat again, go over to calc. It's always one bar stats. There's no frequency, so I just literally hit enter, and it gives us the information, right? So my mean is going to be 5.2. My standard deviation is going to be, let's go back to it, right? OX is 2.56, so I have 2.56. And the variance is just this number squared, okay? So my OX squared is going to be 2.56 squared, all right? Whatever that answer is. All right, so now let's go ahead and put in my new data and see how that compares. So my new data is, I'm going to go back to stat, go to edit, and I'm going to add 4 to each of these, right? So 9, 11, 13, 7, and 6. Okay, now I'm going to go back to stat, go over to calc, one bar stats, enter, 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 and it gives me my new data, right? So now my mean is 7.2, okay? And I noticed something was wrong right away because I went back to my data and instead of 11, I had put 1. So my mean is 9.2. Let's correct that, which makes a lot more sense, okay? My mean is 9.2. My standard deviation is 2.56. And then my variance is going to be 2.56 squared. All right. So what does that mean that I just realized, right? So I know that, well, the only thing that happened is my mean went up, right? It went from 5.2 to 9.2, so this got added 4 to it. My standard deviation stayed the same, and my variance stayed the same. Okay, so adding 4 to each value, right, literally just makes the mean go up by 4 plus 4. And then my standard deviation, right, how spread out the data is, and the variance is exactly the same. Okay, all right. So now I'm going to go ahead and take each of the numbers, go back to my original. Let me do this in a different color so you can maybe see it a little bit better. So I'm going to take these numbers right here, and I'm going to double the values. So 5 doubled is 10, 7 doubled is 14, 9 doubled is 18, 3 doubled is 6, and 2 doubled is 4. So I'm going to go to my calculator again, go to stat, go to edit, and now I'm going to take these numbers and I'm going to double it, right? So this is 5 doubled is 10, so on and so forth. So let me just make sure I type these numbers in correctly. I have 18, and again, I'm taking my original set, 6 and 4. Okay, so now let's do my test, right? Go to calc, one bar stats, enter, enter, enter. And now let's see what happens to each of these. So my mean now, it went from 5.2 and it's 10.4. So my mean got doubled. Okay, now let's look at my standard deviation. My standard deviation, did it change? Yes, it did. It's 5.122 now. So my standard deviation is 5.122, which means that it's this number, right, squared. So this, I'm sorry, not squared, it's doubled. So this also got doubled. If my variance is standard deviation squared, this is going to be 5.12 to the second power, right? So this also gets multiplied by 2, all right? So if I double the values or I triple, quadruple, the same thing is going to happen to the mean, the standard deviation, and the variance. All right, so that's good for us to know. I just realized something, so I wanted to come back. The variance is going to be this squared, so this is really the same thing as multiplying it by 4. But what I want to show you is a visual, right? So if I have the original data set, the 57932, right, that's going to give us something that looks like this, right? It's going to give our normal curve. And then if I add 4 to the values, what's happening is it's getting shifted over, right? So it's getting shifted over 4. So we can see that the mean is going to move over by 4, right? You'll see that? So the mean was over here. Here's our mean, and now this is going to be our mean plus 4. So that makes sense that this is happening, right? Makes sense that this part, the mean is getting moved over. The standard deviation and the variance doesn't change, right? Because it's still the spread of it is still going to be exactly the same. Do you see this? Whereas if I double, right? Let's go back and put our original. So here's our data. So if we have our original set of numbers here, falls on the normal curve. And if I multiply the values by 2, what's happening here? Let me see if I could draw this in a different color. Multiplied it by 2 means I'm taking that graph and I'm stretching it out. So it's going to look something like this. Each of the values are going to get doubled. So if I were to draw it even a little bit more dramatic, it's going to get spread out. Okay. So our mean, what's happening to our mean is it's also getting multiplied by 2. So this is going to get 2, right? Which makes sense. Our standard deviation is, since it's getting more spread out, that's also going to be multiplied by 2. And our variance, which is the standard deviation squared, is times 2 squared, which is the same thing as multiplying by 4. All right. So that should definitely help you go through and relate that a little bit more. I'm going to ask you to pause the video and try this question, please, and then play back the video and see if you're right. All right, so we're back. So for the original data, the mean should be 7. You should get that the mean is 7. The standard deviation is 2.98, and the variance is 8.90, which is standard deviation squared. So this is the mean of the actual data. So if the number of flowers was getting doubled, right? That means that the mean gets doubled. So the mean 7 times 2 is 14. The standard deviation is also getting doubled. So 2.98 times 2 is 5.97. And the standard, the variance is going to get times 4. So that's going to be 35.6. Okay. So if you, what did we just learn, right? If we have a set of data and we are adding a number to it, right? What that means is the mean also gets added, the same number. The standard deviation and the variance stays the same. This is our pro tip. This is what we just learned today, right? That's if we're doing adding or subtracting, okay? Adding a negative. Um, Whereas if your data is getting multiplied by something, multiplied by n, what's happening is your mean is getting multiplied by n as well. Your standard deviation is getting multiplied by that same number, and your variance is getting raised. It's going to be times that number squared, okay? So I just want to end with a couple of examples that are there for you. And it starts with question 0 before we go into this question right here in your actual packet. So go ahead and try some problems and check your answers to make sure that you're good with today's lesson. All right, good job. Good job.